Hi everyone. In this video we're going to do a quick review of radical expressions, review the simplifying and some of the rules since we've already done some of this in class. And then I'm also going to talk about adding and subtracting radical expressions. So when you simplify radical expressions, you know that it's in its most simplified form if the index, the n part here is as small as possible. So that would be, this 4 right here is the index. The n would be small as possible. The radicand contains no factors other than 1 that are nth powers of an all that means is this is fully simplified. There are no fractions. And then in Algebra 2, we say that it's not finished if there is a radical in the denominator. You would need to rationalize that denominator. Okay? So something like this that we did, you know that 625, we're taking groups of 4, right? Because it's the 4th root. So 625 is 25 times 25, which is, of course, 5 times 5 times 5 times 5. So there's a group right there. So the 5 comes out. If I divide 28 by 4, I'm going to get 7. So I'm going to have b to the 7th. And I'm going to talk about that absolute value here in a minute. And then if I take 23 divided by 4, it will come out 5 times, right, with 3 left over. So that would be k to the 3rd. Now, remember that this is an even root, and these came out to be odd, so you would put absolute value around that. So here are a couple more examples of how we would simplify. Once again, we have the square root. So when we take the square root of 25, that would be, of course, 5 times 5. So this is a 5 that comes out. This is the square root. 4 divided by 2 is a squared. And then 9 divided by 2, it goes in 4 times, with 1 left over. Okay? And so since that's a square root, we're looking at these. This is an even power, this is an even power, no absolute value needed. All right, let's do this one. This is cube root. We don't worry about cube roots, absolute value in cube roots. We just go ahead and simplify. So this is 25 times 5. So 5 times 5 times 5. So there's a group. That comes out. M to the 30th, 30 divided by 3 is 10, right, with none left over. And then 3 goes into 20 6 times, with how many left over? 2. So you write that in there, and no absolute value needed. Okay, so now that we've learned to simplify radicals, we're going to take that skill and we're going to add to it by learning to add and subtract radicals together. There are a few rules, not very many. The first one, and I want you to copy these in your composition notebook. The first rule is that you may only add like radicals. In other words, they have to have the same index. They have to be square root, cube root, 4th root, and they have to have the same radicand, or the inside of them has to be the same. All right? The second rule is that you may need to simplify them. Like they may be like the square root of 20, which can be simplified further before you can add or subtract them. All right? So with those rules together, let's look at a couple of examples. So you can see this down here. I have negative 3 times the square root of 7 plus 4 times the square root of 7. And one way you could think of this is that the square root of 7 is like an apple, right? So I have negative 3 apples plus 4 apples, and that leaves me 1 apple, square root of 7, right? Because these are the same, they're the same root and the same inside, then I have negative 3 plus a negative 4 is negative 7, square root of 17. So those are pretty easy. You know, if I have 2 square root of 6 minus 3 square root of 3, these are not the same. We have apples and oranges, and so you can't add the coefficients together. They have to be exactly the same before you can add them. So you might just have several terms there. So here's an example of one that might need to be simplified first before you added the terms together. Because if you look at them, you see that this is the square root of 3 and this is the square root of 27. Not the same, so I couldn't add them together. But what I notice is the square root of 27 can be factored. It can be factored into 3 times 9, and 9 is 3 times 3. So I have a group that could come out. So the square root of 27 is going to be a 3 on the outside and a 3 left on the inside. Okay? Now, this 3 right here that was already there stays outside here. So this term right here would actually be 9 square root of 3. Well, that's kind of handy because I have negative 2 square root of 3. So negative 2 square root of 3 plus 9 square root of 3 is 7 square root of 3. So what we did is we simplified this term. We now have the same radical for both of them. We have the same square root for both, even though this is funky. And then we added them together. Okay, one more example. We can do this, and we're going to practice these some more in class. But obviously, these are going to have to be simplified. So let's take one at a time and simplify them. So we're going to take this first. I'm going to do 9 times 5. That's going to be 3 times 3, right? So that comes out. The 3 stays. So I have 3 times 3 times the square root of 5, or 9 square root of 5. Okay? Now I'm coming up here to 80. I'm just going to do something simple like 10 and 8. So this is 5, 2, and then 3 2's, right? So I have this group, and I have this group. So there's already 5 out here, so this would be 5 times 2 times 2 square root of 5. So I have, and I'm going to leave that negative on there so I don't forget it, 4 times 5 is 20, so minus 20 square root of 5. All right? And then when we do 20, we have 4 times 5. 4 is 2 times 2. That's a group. Bring this down. This is plus 4 times 2 square root of 5 plus 8 square root of 5. So now I'll have square root of 5 on all the terms, and so I add, it's like apples. I've got 9 apples minus 20 apples plus 17, or plus 8, sorry. 9 plus 8 is 17. 17 minus 20, 17 square root of 5 minus 20 square root of 5 is 3 square root of 5 negative. All right? And that's how you do that. So be prepared. We're going to do a lot of these in class. I think they're kind of fun. They're almost like a little puzzle. Just keep the rules straight. See you in class.